Alright, this lesson we're looking at reducing balance loans. So reducing balance loans, when you borrow some money, so you have a loan, and then you make regular repayments to pay off the loan, but the loan also has some interest. So the loan keeps growing and you'll keep making payments and hoping to pay off your loan. So in a recurrence relation, this is what it would look like. Vn plus 1 equaling some sort of interest rate being multiplied your current value. That is the interest rate of the loan. But then we're taking some money away from the loan. So we're paying off the loan by making some regular payments. So here's an example. If we borrow $1,000, interest rate is 15% per annum, but it's compounding monthly. And the payments that we're making is monthly payments of this much, and we're doing it 4 times. And we're asked to just represent it in a recurrence relation for this question. So obviously V0 is going to be 1,000. That's our starting value. Our interest rate needs to be calculated by dividing the 15 by 12 because we're making monthly payment. So it's 1.25% every month. Now that expressed as decimals, and putting the 1 at the front as well, will be this. So we're multiplying this on top of our value every month. But then because we're making payments to pay off the loan, we're taking money away from the loan by this much. So this is what's happening every single month, going up by this interest rate and then making monthly payments. So we're reducing the loan. Now we're asked to calculate what's happening in this loan. This word recursively, you'll see this a lot when we're doing this type of questions where we have a geometric relationship as well as a linear. So we have 2 in 1, then you'll see this word recursively. It just means like repeat the process, and the process being like doing the times and the minus all in one, and do that repeatedly for 4 payments. So do it 4 times. That's what it's saying. So what you are doing, you are going on your calculator. You are typing in the value for the interest rate. Nope, that shouldn't be your first step. Hopefully you realize that. Your first step is to put in your starting value. And then what you're doing after is putting in the recurrence relation. So 125 times. And where you see Vn, that's where we put our value, this value, but we use Control minus to bring that down here. That's going to be helpful for us going forward. And then we put all of the rest in as well. And then we do it once. And then because we brought this down using the answer button, if we just keep pressing enter, it's going to repeat the process for us. So we start with 1,000, that's our initial value. After the first repayment, this is what we have, second, third, and fourth. So that's what I've written here. And the next question says, what is the balance of the loan after 2 payments? So you just have to read off V2. And then the last question says, is the loan fully paid out after 4 payments? And as you can see, after the 4 payments, we have very little amount left. That's like 4 cents. But obviously that's still money, and so it's not fully paid out. So the second part of the question, how much will the last payment have to be so that the loan is fully repaid after 4 payments? So obviously, instead of just making this amount of payment that's happening every time, for the last payment we should put in extra 4 cents to make sure that the loan is fully paid. And the next thing we're looking at today is annuities. So an annuity is when we have a certain amount of money in an investment, or it could be in a bank account, and obviously it's making some interest. So some percentage that we're making on top of this lump sum of money, but we're also getting some payments out of it, so we're getting paid. So because we're getting interest, this value of this total amount is growing a little bit, but because we're taking some money out, we're getting some payments, regular payments from this money, the value is also going down a little bit at the same time. So very, very similar to what we've just done here, where the value of the loan goes up a little bit because of the interest rate of the loan, but because we're making repayments, it goes down. But obviously the difference here is you already have this amount of money. Like, this is a good thing to have, whereas the loan is something you owe. This is something you already have, which is growing, which is nice, but then you're also getting paid, which is a good thing, but then obviously in return this value is going down. So to show this, we're following the same sort of format where we're multiplying the interest rate to our value, and we're obviously taking some money away because we're getting paid. So this is an example. Peter here has an annuity. So out of this amount that he owns, he already has this amount in his superannuation, and it's making some money for 8.5% per year. That's the interest. But then Peter's also getting some payment of $2,400. So obviously we can put this into a recurrence relation, and because we're given the interest rate per annum, if we'll divide this by 12 because we're getting it every month, and then when we divide it by 12, this is the value that we get. So this, as decimals, we can represent it like this. So our recurrence relation is going to look like starting value of this much, Vn plus 1 is the interest rate in decimals times the value, but then minus the amount that's getting repaid that Peter's getting from this investment or this superannuation. So this example here, I would like you to have a go on the CAS. Make sure you know how to do it on the CAS. But the process, obviously, I've just showed you before in this video. So we're multiplying this value, taking this value away, and our starting value is this. So if we repeat this process on the CAS, these are the values that we're getting for the first payment, second payment, and third payment. And the question is asking, after 6 payments, if there's any money left in the annuity. Because if annuity is fully paid out, like the amount of money you had is fully paid out to you, obviously there'll be nothing left. And from the calculations, if you do it 6 times on the CAS, you're left with this much, less than $1. But obviously still it's not fully paid out, so it's not paid out for the final payment. but because every payment is this much, for it to be fully paid out in the final payment, we can just add this value on top, and this can be our last payment, so the annuity is fully paid out.